All right, DTC is back today to review the Rokid Max glasses. It's the first generation from Rokid, but the second generation has the exact same display and optics. So for the sake of this review, we're looking at all current display glasses from Rokid. Taking a look at the glasses themselves, these have some of the more unique designs, I would say, amongst the other brands that we've reviewed, in that they're a little bit more bug-eyed, a very slender look at the front of the glass. Um, Again, they come in with an included shield so that you can pop this on and have a complete black background to your viewing experience. But again, completely occlude all light that's coming in from the environment. So for the purpose of any AR-like experience, these are a complete no-go. The rest of the device operates just like you'd expect any display glasses to operate. It comes in with a USB-C cable to connect to your laptop, tablet, gaming device, or mobile phone. The hyperflexion that you see in the Rokid stems actually allows for a wider range of comfort. So it's really, really nice to see that in these particular pair of glasses. It would accommodate quite a large variety of head sizes with similar pressure applied by the temples. But to turn these on, we plug in on the left stem, the USB-C cable, and now we can start seeing what we can see through the glasses. One area that I think Rokid does a maybe disingenuous job of marketing is the reduced light leakage that you see coming through the device itself. They claim that there's a 90% reduction in the light that passes through the world side of these glasses, and frankly, I just don't understand what this is actually referring to because it's just frankly not true. There is a significant amount of light, as you can still see right now, that is coming through the front of the glasses. So this is a pretty confusing part of the overall marketing. But the display is a 1080p, likely Sony microdisplay. We'll take a look at this when we get into the display module a little bit later. The power draw of the device is very, very similar to some of the other devices that we've seen before. Roughly a 1 watt power draw idle with no display on. So if we were to turn this display ambient mode, we would do about 1 watt power draw. And then on the lowest brightness, we have about a 1.5 watt power draw, which is comparable to the rest of our devices, except for Raineo, which does have a much larger power draw than the rest of its competitors. But on the high end, on the high brightness side, the power draw for these glasses is actually much lower, around 2.2 watts. And so versus all the competition here, we get a much, much lower power draw. Again, I'm not sure exactly why this is because we're likely using the exact same Sony 0.6-inch panel that we see in all of the Viture Pro and X-Real Airs that we've analyzed before. But we'll take a look and see if we can find anything in the teardown to give us an indication as to why that might be. The overall design of the glasses, especially while in operation, is quite nice. The temples themselves are quite cool to the touch, and so you won't feel much in the way of heat that is transferred to the side of your own temples. But you will have quite a bit of heat coming from the front of the glasses. You can actually even see there are air vents included right above the optical module that actually do get quite warm. And so to the touch, the front of the glasses can get quite warm as well. But again, unless you're wearing these for hours at a time, which hopefully is the goal for some of these manufacturers, you will not see much issue with that. Rokid also has the diopter adjustment mechanism that we've seen from Viture, where you can actually see that the display and lens modules are moving in Z within the actual optical module. to essentially compensate for some nearsightedness that people might have without having to actually put in any of the prescription lenses inside the optical path. So again, very, very nice feature, especially around these price points. And would love to see this become a standard feature, knowing that essentially you are letting the user dictate their field of view. It's a much better user experience than putting in another lens and continuing to add heft to the overall device. So great to see these on Rokid and Viture Pros together. An unfortunate downside to the Rokid glasses is that while they are set up for 3DOF tracking and pinning of the screen in virtual space, that is only enabled via a separate hardware purchase from Rokid. You must buy their Rokid station to be able to enable that that screen pinning with your device. That is unlike some of the other competition, like the Vitures that do have a native app that you can just download on a device that you already own, and you don't have to have this external new piece of hardware that you're carrying around. So it's unfortunate because I think Rokid could have gone the exact same way with this device, but instead chose to maximize the hardware sales that we got here. So we'll take a look at the glasses now, break open the optical modules, and expect to see very similar display and lens modules as we've seen in the competition within this space, but there may be something that surprises us, like we saw in Viture Pro. Accessing the optical module for the Rokid Max is one of the most frustrating aspects of disassembling and reviewing this device, because the only way to actually cleanly access is to remove the front tinting lens elements, which are protecting the screws that connect the front faceplate to the back faceplate. This is done by removing the actual lens that has been glued in to the frame and requires quite a lot of manual disassembly work, unlike the much easier user access retainer clip method that most of the other brands are using. So Rokid, unfortunately, is choosing immediately from the onset the least consumer-friendly serviceable approach, where you will have to remove this lens either with heat, alcohol, or combination thereof, so that you are able to gain access to the optical module, where the screws for final disassembly are actually located. Once you have finally removed the two lenses and hopefully not scratched the delicate half mirror in the process, you'll have access to the 4 screws, Phillips head screws, that are holding both the top bracket and the bottom bracket of the back side of this faceplate together. Additionally, Rokid has installed an anti-tamper sticker here that will show the manufacturer that you've actually entered this device should you choose to do any disassembly work yourself. So again, much more unfriendly to the consumer manufacture process. Once we've removed all 4 Phillips head, we can then also cut the glue seam line that Rokid has between the front and back side of the faceplates, and ultimately disassemble this, removing the front faceplate from the assembly, having the top side that we had to pry open to even get access to be able to get this far, and see finally the internals that we have here, including 3 Phillips head screws on each side, holding both the display diopter adjustment mechanism as well as the main logic boards, followed by a water ingress sticker that tells Rokid whether or not your unit has been exposed to moisture, as well as the flat panel connectors from both the right and the left temples, which ultimately provide the power and data signals for our display. We can see the turn knobs for our diopter adjustment mechanism. Looking closer at our unit, we can see that there is one large piece of thermal tape on the front side of the metal chassis. And we can peel this back to see all of this shielding tape and thermal transfer tape that we have over the entire unit. This reveals to us 3 more Phillips head screws on either side, holding the hinge mechanism in place, both on the left and the right temples. And so this tape will be removed as we get access to the main logic board in the center of the nose bridge here, since it also doubles back and covers likely some components on the rear side of this board. Having removed that thermal transfer tape, we can actually now get a good look at all of the central logic board, including the display controller, again another Lontium 7T91 UXC that we've seen in most of our display classes so far, and the ST microcontroller. It's interesting that Rokid has chosen to put all of the key processing components on the main board here, actually preventing the need for very discrete boards in the left and the right temples, and allowing us to potentially see bigger batteries that are put into the temple long term. But we'll take a look at the teardown and see exactly how much room they have in each temple at a later date. We've removed the left stem from the display glasses, and we can see that we still get an image in the display, which means that the proximity sensor for detecting whether or not you're wearing these glasses is not critical for operation. What's nice to see is that we are still getting a very clear image, and so we've not done any damage through the very destructive disassembly process that we had to enter with. Next, we'll disconnect the power and data pogo pin connector that we have here, and remove the right stem so that we have access to the full optical assembly. With the optical module fully disassembled and disconnected from the rest of the device, we can take a little bit closer look at everything that's housed on the optical module. And for the most part, it includes everything that drives the actual unit. We've got the microcontroller, we've got the audio IC, the display IC, and obviously the display and optics connector. What we also have here is a microphone coming down, sitting directly on the nose bridge. Pretty interesting location, much more central than many of the other units, and likely to give better audio quality when eventually we have the microphone picking up voice and audio for ambient environment processing. Once we've removed the right temple, it's relatively straightforward to get into the optical module of this unit. There will be 2 Phillips head screws connecting this bracket, which holds the microphone flat panel cable and its connector to the main logic board. We can easily disconnect this flat panel connector, revealing what was likely the original name of these Max AR glasses, just the Rokid glass, as well as the microphone connector and a QR code, likely some internal manufacturing traceability mark. From here we have 2 more Phillips screwdrivers on either side of the main PCB to remove before we can disassemble and take off the main logic board from the optical module. We'll also need to disconnect 2 display connecting cables on either side of the logic board. We can just pop up the ZIF connector on either side. And now the logic board will allow us to remove the connectors for the displays and take out the main logic board, which we can take a look at later. This dual side board houses a lot more of the control circuitry and the main driving ICs for the audio and the displays than most of its competition, which also explains why the temple gets quite warm compared to all other display glasses that we've looked at. Next, we have the optical modules, both the left and the right optical modules. These are held in place by 3 Phillips head screwdrivers each, as well as a bead of glue around the seam between the diopter adjustment mechanism and the display module to the actual lens module in the birdbath optic. So we'll take apart the right optical module here by just removing these 3 Phillips head screws. And now we can remove the right display module from the birdbath module inside here, revealing the display module sitting on the diopter adjustment mechanism. Here we have a very similar control mechanism to what we saw in the Viture Pros, where this linear screw that we have here controls the Z position of the display module relative to the reflective surfaces inside of our birdbath optic. And so the interesting part is that they're not 2 separate flat panel connectors. We have a single flat panel cable from the display that is threaded all the way through this diopter adjustment mechanism. The display module for these Rokid AR glasses are very similar to what we've seen in most of the teardown so far, but most similar to Viture in that we obviously have the backing plate, which is a metal component that actually has the screw which drives the display in Z to adjust for the different myopic prescription you may have. The one difference that Rokid has presented here is that there is no metal component directly on the back side of the microdisplay. Instead, there's just a piece of thermal tape with conductive graphite that we see taken off the back side of our display here. This is not great. We essentially do not have a metal heat absorber directly in contact with the display, because if you remember, the display is going to have an air gap to this component based off of how much myopic adjustment you have to do on the diopter adjustment mechanism. So this means that this display will run very hot. So this could lead to very low lifetimes and an overall degradation of the picture quality in our OLED microdisplay. The OLED microdisplay is similar to what we've seen before. It is a Sony ECX343E 0.68 inch OLED microdisplay, 1920 by 1200p. So technically we can run this at 1200, but I suspect we have Rokid reserving around 120 pixels on either side, where we may have some significant optical distortion, which is why this product is advertised as 1080p. One thing we'll note when we look at the optical path is that Rokid also does not use an integrated quarter wave plate on the display. Instead, Rokid uses just a linear polarizer, and we can test that while the display is on. We can take a strip of linear polarizing material and put it on top of our OLED microdisplay. When the axis of this linear polarizer is aligned to the axis of the linear polarizer on our microdisplay, there's no real brightness loss as we put the linear polarizer on or off. But as we rotate this linear polarizer 90 degrees relative to the axis of the linear polarizer on top of the OLED microdisplay, we see that the image has disappeared, essentially meaning that we have complete absorption of the light that's coming out, and that would only be possible if we have linearly polarized light coming out of our OLED microdisplay. So it looks like Rokid is using a very similar design to Viture, where they will not need 2 quarter wave plates in each of the birdbath modules. Only 1 quarter wave plate on the half mirror surface. Very nice to see that. And finally, we have our field lens element. This just magnifies the picture to compensate for the curvature that we have in the half mirror, reflecting the image back to the user's eye. So relatively nice and clean design for the display module, but unfortunately, the lack of a metallic backing to our OLED microdisplay means that we will constantly have this running very hot, especially if you're always at the brightest setting. Now we can see the full optical module design, all the way from the backing plate, which houses our display module, to the backing shield material that helps attract some, but definitely not all the heat away from our display with our linear polarizer on top of the display. The linearly polarized light travels through our field lens, magnifying the lens to ultimately compensate for the curvature that we'll see in our half mirror. But once the light comes out from the field lens, it will bounce off of the reflective polarizer, the backside of this element, into the quarter wave plate, circularizing our polarization, bouncing off of the half mirror, back through the quarter wave plate, counteracting that circular polarization, ultimately giving us a polarization state that can pass through our reflective polarizer and exit out to the user's pupil. So again, quite a nice and efficient optical design with slight manufacturing challenges. The biggest concern in this entire design is the lack of any heat sink to the display panel. Displays generally run quite hot as we power them with hundreds of milliwatts of power, and if the only thing that is pulling heat away from this display is a tiny piece of tape exposed only to air, we will have significant thermal buildup in this display. So overall, it'd be really nice to see Rokid integrate more thermal transport on the backside of their OLED microdisplays in future generations. And with that, we finish our teardown of the Rokid Max AR glasses. Again, very similar to the Rokid Max 2s in terms of optical design, but with slightly updated design language. Overall, a very, very standard birdbath design with the nice feature inclusion of the diopter adjustment mechanism to prevent the use of prescription lens inserts for a majority of the population. That said, there are some significant drawbacks to this design over most of the other display glasses that we've seen so far, namely the lack of a heatsink on the back of the OLED microdisplay. This ultimately will lead to much higher temperatures at the display panel itself, ultimately lowering the lifetime that you can expect out of these devices. So would be nice to see that in future designs. We do have some heatsink included on the very, very hot running display panel. Most importantly, the biggest drawback to this design is the lack of user accessibility to the internal components should you need to access this for a repair or replacement without having to almost catastrophically destroy the unit. There is a lot of glue both on the front-facing lens elements that ultimately get you access to the screws holding to the plastic components of the front face housing together, but also around the optical components in the birdbath modules themselves. I'm fortunate to see that Rokid has chosen a much less user-friendly design than all of their other competition, but nevertheless, for under $300, it's a great pair of glasses that you can get with pretty good color reproduction and a 1080p 120Hz screen. So thanks again for watching. That does it for our display glasses reviews and optical teardowns for a while. We'll move on to some other true AR solutions next. But as always, if there's anything you want to see or hear or learn about, put down in the comments below. Thanks.